All right, chapter 5.8, coordinate proofs. Essential question is, how can you use a coordinate plane to write a proof? And what you will learn in this chapter section is how to place figures in a coordinate plane and how to write a coordinate proof. So let's take a look. All right, so placing figures in a coordinate plane. A coordinate proof involves placing geometric figures in a coordinate plane. When you use variables to represent the coordinates of a figure in a coordinate proof, the results are true for all figures of that type. And we'll talk about that as we go. So example 1 says, placing a figure in a coordinate plane. Place each figure in a coordinate plane in a way that is convenient for finding side lengths. Assign coordinates to each vertex. So we're going to do a rectangle, and we are going to do a scalene triangle. So for starters, to solve this, the solution states that it is easy to find lengths of horizontal and vertical segments and distances from the origin 0, 0. So place one of the vertices or one vertex at the origin and one or more sides on an axis, be it either the x-axis for a horizontal side or a vertical side, x or y-axis. Okay, so I'm just bringing this in from the book. So here's what they're talking about. So if we were to put the corner at the origin, like it said to do, and put a side on the x-axis or on the y-axis, or both in this case, which makes it easier, then we can represent lengths. So let h represent the length and 8k represent the width. So the origin is centered, is 0, 0. That's the coordinates of the origin. So if this side is length h, it means you went to the right h units. That's your x value. I went to the right h up 0. So I'm still on the x-axis. This is the point h, 0. If I start at the origin and go up to k, that's a distance of k up, which is y. So this point here would be over 0 up k, giving us the point 0, k. So the point over on this side is over h units up k units, so it's h, k. So we have 0, 0, h0, hk, and 0, k. Okay. All right, so here we go. Next one, the scalene triangle. So again, notice we put it in the corner, put baby in the corner, and put one side on one of the axes. So they chose to put it on the x-axis, and they said we have to use 3 different variables here. So we have the point 0, 0, and if this is a distance d, they're calling that d. And then there's another point here. Well, it isn't over d, it's not as far. So the f is less than d, if that makes sense. We went to the right less than d, so that's f, and we went up a distance of g. So if I did that over here, that would mean this is a distance of g up to this here. And f would be a distance from 0 to the point. So this right here is distance f. So this is f0, this is fg. This right here would be over 0. Oops, what did I do? Over 0 up g. So this point right here would be 0, g. And this point here would be over f up 0. Okay, so we needed 3 different variables there. Okay, so that it can be a little confusing, but if you just give it some thought, it's actually not that bad. It's an unknown distance given a variable. Okay, so let's take a look how to use this. Okay, example 2 says writing a plan for a coordinate proof. Okay, so it says write a plan to prove that ray SO. So let me highlight that. Let me choose the ray and let's make it a little thinner and let's use green. All right, now this is in my way. Isn't that beautiful? Anyway, let's put it here, and then I'll just move it if they want to be that difficult. So there is Ray. Whoops. It's the other way around, isn't it? It's this way. Ray SO, meaning the initial point is S. That's too thick. The initial point is S. Actually, it wasn't too thick. So let's do that. Okay, so the initial point is S, terminal end is O. SO, this is Ray SO. Write a plan to prove that Ray SO bisects P angle PSR. Okay, so we want to prove that this angle and this angle are congruent because that ray bisects the whole angle. So given coordinates of the vertices of POS and triangle ROS. So vertex P is at -3, 0, which is here. Vertex S is at 0, 4. And vertex R is at 3, 0. And then we have the origin where SO goes through the origin 0, 0. Those are all the points that we have. We have to prove that ray SO bisects angle PSR. So how are we going to do that? Well, use the distance formula to find the side lengths of POS, triangle POS and ROS. Then use side congruence theorem. So I'm going to do that. So here we go. How we do that? Well, in triangle POS, I'm going to say, okay, the length of PO equals, PO is right here, Y2, actually it's just a horizontal line, so it's just the differences of your x's. 0 minus a -3 is 0 plus 3, so PO is length 3. Okay, I'll do the other one in blue. RO goes from 0, 0 to 3, 0. So it's 3 minus 0 plus 0 minus 0, which is 3. That's a distance of 3. So RO is 3. So now I can say that PO is congruent to RO because we measured them as lengths 3. The distance from S, which is 0, 4, down to O, which is 0, 0, that's a distance of 4. Okay, so I'm going to say SO equals 4. The length of SO equals 4, and the length of SO equals 4. It's in both triangles. So now we have two sides, and now we have to find the length of PS. So PS equals, in this case, we have to use the distance formula because it's not vertical or horizontal. So let me just move this over so I'm not running into the blue. So PS equals Y2, X2 minus X1 plus Y2 minus Y1 is what it is, right? So 0 plus 3, 0 minus a -3 is 0 plus 3 squared plus okay, so X minus X squared plus Y minus Y. Y2 is 4, Y1 is 0, so that would be 4 minus 0 squared. So PS is going to equal 9, which is 3 squared, plus 16, which is 4 squared. That makes PS the square root of 25. So therefore PS equals 5. Okay, so now we have to do SR. PS. Let's call it P or RS. Okay, I want to go in the same order. RS. So I went PS. R corresponds to P. So I want to say RS equals the square root of X2 minus X1, 0 minus 3 squared plus 4 minus 0 squared. RS equals -3 squared is 9. 4 squared is 16. RS equals the square root of 25. And therefore RS equals 5. So PO is congruent to RO. They're both 3. SO is congruent to itself, 4. PS is congruent to RS. They're both 5. So we just use the distance formula to find the side lengths. So we saw that all 3 sides are congruent to the other corresponding 3 sides. So we have SSS congruence. So we can say that the triangles are congruent. Okay. So now that we know the triangles are congruent, we know PO is equal to RO, which is right here. Okay. Finally, oh, and we wanted to, no, that's what we're trying to find. We're trying to find that these got bisected. So if PSO is congruent to RSO, they have to be by corresponding parts of congruent triangles congruent, right? The 2 triangles are congruent by side, side, side. Then every corresponding part has to be congruent. So angle PSO and angle RSO are corresponding. So therefore they're congruent. That also implies that the ray SO did in fact bisect angle PSR. Okay, so that's how you do a proof using coordinate plane. Now you should be able to do problem number 7. All right, example 3, applying variable coordinates. So place an isosceles triangle in a coordinate plane. Isosceles triangle, 2 sides are congruent, right? Isosceles triangle. Isosceles right triangle, 2 sides congruent, and so the 2 legs are congruent, and there's a right angle. So place an isosceles right triangle in a coordinate plane, then find the length of the hypotenuse and the coordinates of its midpoint M. Okay, so here we go. Solution, place triangle PQO with the right angle at the origin. So there it is. Always use the origin for one of your vertices and put one side on the x-axis or y-axis. So since this is a right triangle, then both legs are going to be on the x and y-axis respectively. Okay, so let the length of the legs be k. So this is a distance of k from here down to here is a distance of k. And from here all the way over to here is also a distance of k. All right. Then the vertices are located at P being over 0 up k, and Q is over k up 0, and the origin 0, 0. Okay, so what we want to do is find the length of PQ. Okay, so PQ, so we're going to write PQ equals, and I'm going to write the formula this time. I didn't on the last one. X2 minus X1 quantity squared plus Y2 minus Y1 quantity squared. That is the distance formula. Okay, let me just move this over here so I have more room to write. So now we're going to substitute in our givens. So PQ is going to equal, well, X2 is, I always like working left to right. So X1 is 0, X2 is K. So if I write this, it's going to be K minus 0 squared plus Y minus Y, which is 0 minus K squared. Okay, so what am I doing here? I'm using these 2 endpoints. Okay, K minus 0 is my x's, and 0 minus K are my y's. All right, so that's where that came from. Now we simplify. K minus 0 is obviously K, and that's squared, plus 0 minus K is also K, but we're going to square it. But be careful, it's not minus K, it's a plus a negative K squared. So then we're going to get PQ equals the square root of K squared plus k squared, because a negative k squared is k squared. Okay, negative times negative is positive. All right, so that is going to give me PQ equals the square root of 2k squared. And if I simplify this, it's going to be PQ equals the square root of k squared times the square root of 2. I can split those up, and that will give me the square root of k squared is k, and I can't get 2 to be a perfect square. It's not a perfect square. I can't take the square root of 2. It's an irrational decimal, non-repeating term, non-terminating decimal. Okay, so the length of PQ is k times the square root of 2. All right. So what did it ask us to do? Find the length of the hypotenuse and the coordinates of its midpoint m. So I have not found where m is yet. I know it's k root 2. So now I have to find the midpoint using the midpoint formula. So the midpoint formula is y, okay, so it's parentheses x2 minus x1 divided by 2, comma, y2 minus y1 divided by 2. So m equals, so I'm looking for the midpoint. So it's the x's 0. I'm sorry, it's not minus, it's plus. I'm thinking of distance. Okay, midpoint is the sum of the x values divided by 2, sum of the y values divided by 2. So here's an x, it's 0. Here's a k, it's 0. So it's 0 plus k divided by 2. The y's would be k plus 0 divided by 2. So that's going to simplify to k over 2, comma, k over 2. Or you could say 1/2 k, comma, 1/2 k. All right, so there we go. The length of PQ was k times root 2, and the midpoint was k divided by 2, comma, k divided by 2. So hopefully you can do problem number 13 now in the exercise. All right, example 4 is writing a coordinate proof. Write a coordinate proof given the coordinates of the vertices of a quadrilateral OTUV. We want to prove that triangle OTU is congruent to triangle UVO. Okay, so we want to prove this triangle is congruent to this triangle. That's the goal. How do we do that? Well, we have reflexive sides, so we have one side in common. Now we just have to prove maybe 2 other lengths because we can't find angle measures with unknown values. Okay, so here's what we're going to do. Segments OV and UT have the same length. How do I know that? Well, OV is right here. It's the absolute value of h minus 0, which is simply h. UT is the absolute value of m plus h minus m, our x values. Well, m plus h minus m minus m is 0. That's the absolute value of h, or simply h. So we know that their both lengths are h. So this is a distance of h, and this is a distance of h. So they're congruent. Okay. Then horizontal segment UT and OV each have a slope of 0, which implies they are parallel. Okay, they are parallel because they both have a 0 slope. How do we know it's a 0 slope? Because I went over h up 0. Your y change is your slope. y over x. 0 over h is 0, so the slope is 0. Okay, segment OU is the diagonal, intersects segment UT and OV. Let me think about that again. Segment OU, the diagonal, intersects UT and OV. Yeah, that's right. So what they're saying here is, here's UT, here's OV, the diagonal, OU intersects, both of them, it intersects at the vertices here and here to form congruent alternate interior angles. Okay, so they are going to use angles here. Okay, so that angle is congruent to that. This angle is congruent to that. Okie dokie. There are other ways to do this, but just going along with the book. Angle TUO, angle TUO, and angle VOU are also congruent because of the reflexive property of congruence. No, TUO and VOU are congruent because of the alternate interior angles. Now they're saying by the reflexive property of congruence, OU is going to be congruent to itself. And there it is. So we have two angles and a side that's not included. Actually, we have two sides that's congruent to itself. So it's side, angle, side, side, angle, side. So we're not talking about this angle. We're talking about angle TUO and angle VOU. Okay, so it's angle, side, angle. So now we know those two triangles are congruent by side, angle, side. And that's that. So that's how you use coordinates to prove two triangles congruent. Now you should be able to do problem number 17. Okay, example 5, writing a coordinate proof. You buy a tall three-legged plant stand. When you place a plant on the stand appears to be unstable under the weight of the plant. The diagram at the right shows a coordinate plane superimposed on one pair of the plant stand legs. Okay, the legs are extended to form triangle OB, which is up here, C. So see how this dot, 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 dot goes through to here. Okay, so the legs are extended to form a triangle OBC. Prove that triangle OBC is a scalene triangle and explain why the plant stand may be unstable. So the definition word here is scalene. That means we have to prove the triangle has three side lengths that are not equal. Okay, so first thing we want to do is find the length of OB. So OB equals the square root of, okay? So it's x2, 12 minus 0, and y, 48 minus 0. So OB equals the square root of 12 squared plus 48 squared. So OB is going to equal the square root of 144, and I need to find the 48 squared. 48 squared is 2,304. So OB is equal to 4 plus 4 is 8, 0 plus 4 is 4, 3 plus 1 is 4, and the 2 does not get added. So the length of that is 2,448, the square root of 2,448. So I'm going to say the square root of 2,448 is approximately 49.48. And since it's not a perfect square, you have to write an approximation. Okay, so there's one side. Now I want to find the length of BC. So let me do green this time. So BC is going to equal the square root of, and I always do this first, but it's the two sets of parentheses squared with a plus sign in between. And then we look at x's. 12 minus 18 and 48 minus 0. That is going to give me 12 minus 18 is -6 squared plus 48 squared. So BC is going to equal this -6 squared is positive 36. And we already did 48 squared is 2,304. Okay, so keep in mind when you're working, if you recognize something that you've done already, just reuse it rather than going to the calculator again. 6 plus 4 is 10, carry the 1. 3 plus 0 is 3, plus that carried 1 is 4. And then we have 3, 2. So we have square root of 2,340, and I need to check that. So the square root of 2,340, we really don't need to do this. That is an approximation of 48.37. Okay, and the other side length is OC. It's this base right here, OC. So OC equals the absolute value of the difference in your x's, 0 minus 18. Okay, or 18 minus 0, either way you do it. Actually, let's do it that way. X2 minus X1, 18 minus 0. So OC equals the absolute value of 18, and therefore OC equals 18. So 49, 48, 18 are three different values. So we just proved that that triangle is a scalene. Okay, so the plant stand would be unstable because OB is longer than BC, so the plant stand is leaning to the right. Okay, since this is longer than this one, it's tilted to the right a little bit, making it unstable. So now you should be able to do problem number 19 in the problem set. Okay, that brings us to the end of chapter 5.8. If you haven't done so already, please do these problems, plus 28 and 29 are review questions. Thanks for watching and have a great day.